Hello, ladies and gentlemen, this is Mr. Loafs. Welcome to IB Chemistry Flipped Classroom. This video is intended to be a very brief review of how to multiply and divide numbers that are in scientific notation without a calculator, or maybe you have a calculator that cannot do scientific notation. This is important in IB Chemistry because on paper 1 you cannot use a calculator at all, and from time to time you might have to do some math and scientific notation on that test. You, of course, in any other circumstance, you can use a calculator to do these scientific notation problems, and there is another video that's available to help you review how to do that. But today we're going to focus on what we can do without a calculator. And this is going to be a quick review, like I said. There are plenty of videos out there on the internet that go into more depth, but I just want to remind you of the basics here. So, suppose we have this problem. 4 times 10 to the third times 2 times 10 to the sixth. Okay, so sorry that's cut off there up a little bit at the top, but we got 4 times 10 to the third times 2 times 10 to the sixth. Let me just rewrite that real quick. Okay, there we go. That looks a little better. So the rule when you're multiplying numbers in scientific notation is you multiply the first numbers here, the base numbers, just as normal. So that's 8. 4 times 2 is 8. And there's 2 significant figures in both of these numbers. So there should be 2 in my answer. So that would be 8.0. And then you add exponents. So 3, 6. 3 plus 6 is 9. So that's 10 to the 9th. And in a case like this, it's very quick and easy. Certainly quicker and easier than trying to use your calculator. So when you have a situation where it's pretty obvious if you know the rules, you should probably just go ahead and do it without the calculator. Let's try another one. Suppose we have 5.0 times 10 to the 10th, and we're going to multiply that times 6.0 times 10 to the 12th. Okay. So again, the rule is we multiply the base numbers as normal, and then we add the exponents when we are multiplying. So 5 times 6 is 30. Now there's 2 significant figures. The way to write 30 with 2 significant figures is 30 with a decimal point at the end. And then we add the exponents. 10 plus 12 is 22. So 6 times 5 is 30. 10 plus 12 is 22. So that is our answer. Now there is a problem with this in that this number is not properly written in scientific notation. If you recall, scientific notation numbers cannot be greater than 10. In fact, they have to be less than 10. So 30 times 10 to the 22 is not in the proper scientific notation format. And if it is required, or if the problem, or for whatever reason, if we're going to express this number properly in scientific notation, we're going to have to change this 30 to 3.0. And then that's also going to affect our exponent. So what I want is I need to make sure that these two numbers are equivalent. 30 times 10 to the 22nd, I need to write something that's equivalent to that, except it's 3 times 10 to some number. The way I like to think about it is the decimal point's right here. I'm moving 22 spots to the right when the decimal point's right there. Well, now if I move the decimal there, to get to the same ending spot, I would have to move 23 spots to the right. So these two numbers are equal. The only difference between them is that the bottom one is written properly in scientific notation and the top one isn't. They're both correct in the sense they're both the right answer to this problem, but the bottom one is the one that's written correctly in scientific notation. So if, for instance, if this was a multiple choice problem, it might very well be that this would be what is listed as the answer. So keep that in mind, that often when we're working with scientific notation, we want to really keep things in scientific notation and keep it in the proper format. So that is, again, a very quick review here of multiplying. When you divide, like let's say, for instance, we have 9.0 times 10 to the 5th. Divided by 2.0 times 10 to the third. So the rule here is these first numbers, these base numbers here, we divide them as normal. 9 divided by 2 in that order is 4.5. And when we're dividing, we subtract exponents instead of adding them. So 5 minus 3 is 2. Significant figures, there's 2 significant figures in both of these figures and in the answer, so that's good. So this is my answer right here, 4.5 times 10 to the 2. It's also properly in scientific notation, so everything's good. Another example, 8 times 10 to the 5th. Divided by 2.0 times 10 to the negative 3. Okay, so again, when we're dividing, we divide the beginning numbers. 8 divided by 2 is 4. And we're going to subtract. Now, watch what happens here. This is 5 minus a minus 3. We have to subtract the 2 exponents. Well, when you do 5 minus a minus 3, that switches these signs. It's the same as 5 plus 3. 5 plus 3 is 8. So their answer here is 4.0 times 10 to the 8th. So there you have it. There's the quick review of multiplying and dividing with significant figures. It is, of course, possible to add and subtract, but that's really going to come up very rarely. And most of the time, you can rely on your calculator. Your calculator can do this. It can put it in scientific notation properly. It can do all of this stuff. But it's just good to know how to do it manually in case it comes up on paper 1, or to see if the answer from your calculator makes sense. Kind of double check if you're putting things in wrong and stuff. So thanks for watching, guys. We will see you next time.